Hey everyone, it's Tumas and welcome back to the channel. Today we're diving headfirst into the world of megastructures, specifically bridges. Have you ever wondered how massive bridges are built across rivers or seas? I mean, think about it. These things are gigantic, and they're holding tons of cars and trucks, and somehow they don't just fall into the water. It's honestly mind-boggling. We're going to break down the whole process, from that initial spark of an idea to the grand opening where cars first drive across. From planning to the final touches, here are the 10 essential steps in building a bridge over water. Get ready to have your minds blown. Before we even think about giant cranes and steel beams, we have to answer a crucial question. Is this bridge even possible? That's where the feasibility study comes in. It's like checking all the boxes before you start a giant Lego project. Engineers head out to the site and start poking around, both literally and figuratively. They'll use sonar to map the riverbed or seabed, take core samples to analyze the soil composition, and measure water depths and currents. We need to know if the ground is solid enough to support the ridiculous weight of a bridge. They also factor in things like traffic patterns, environmental concerns, and even potential earthquake risks. It's all about making sure that this bridge is actually a good idea, and not going to crumble under its own weight or cause a major environmental disaster. Alright, so the feasibility study gave us the green light time to start designing this bad boy. Architects and engineers team up to create the bridge's blueprint, like the ultimate game of SimCity but with real-world consequences. First, they figure out what type of bridge is best for the location. Suspension bridge, cable stayed, beam bridge. Each design has its own strengths and weaknesses depending on the span, the terrain, and the materials. Then comes the really detailed stuff, calculating stress points, load distribution, and figuring out the exact materials they'll need. They use computer modeling to simulate different scenarios like high winds, heavy traffic, or even earthquakes. This stage is all about precision and making sure this bridge is built to last. Hold your horses. Before we start digging, we need to make sure we're not messing things up for the environment or breaking any rules. This step is all about getting the thumbs up from environmental agencies and government bodies. They review the project plans to make sure we're not going to disrupt wildlife habitats, pollute the water, or create some other ecological nightmare. There are a ton of regulations and permits required for a project of this scale, and it can take a while to get everything approved. It's a crucial step to ensure we're building responsibly and keeping the environment safe. Okay, things are getting real now. It's time to build the bridge's foundation, and since we're over water, that means going deep. We're talking about driving massive piles, these long cylindrical columns, deep into the riverbed or seabed. These piles are like the roots of the bridge, anchoring it firmly in place. They use giant hammers or vibratory drivers to hammer these piles down until they hit solid ground. It's a noisy process, but hey, you can't rush a strong foundation. The deeper and stronger the foundation, the more weight the bridge can handle. With the foundation secure, we start building the bridge's vertical supports, the piers and abutments. The piers are those tall, strong structures that rise out of the water and support the bridge's span. Abutments are similar, but they're located at the ends of the bridge, connecting it to the land. These things are built to withstand incredible forces, from the weight of the bridge itself to wind loads and even ship impacts in some cases. They're typically made of reinforced concrete and require massive amounts of material. It's like building a skyscraper, but horizontally, and with water constantly trying to mess things up. Now for the part that starts to look like an actual bridge, installing the superstructure. This is the part of the bridge that spans the water and carries the roadway. Depending on the bridge type, this could involve lifting giant prefabricated sections into place with cranes, or slowly pushing the entire structure out from the sides. It's a delicate dance of engineering and logistics, requiring meticulous planning and coordination. It's like putting together a giant jigsaw puzzle, but with way higher stakes if you drop a piece. The superstructure is in place, so now it's time to make it actually drivable. This step is all about laying down the bridge deck, the concrete slab that forms the road surface. They also install drainage systems to prevent water from pooling on the bridge, which could be dangerous for cars and also erode the structure over time. Then comes the finishing touches, laying asphalt, painting traffic lines, and installing barriers to keep everyone safe. A bridge is more than just concrete and steel, it's a complex system with its own network of utilities and safety features. This step involves installing lighting for nighttime visibility because, let's be honest, nobody wants to drive over a dark, spooky bridge. There are also communication cables for emergency services and sometimes even pipelines for water or gas. They also install safety features like guardrails, crash barriers, and pedestrian walkways. It's all about making the bridge functional, safe, and ready for anything. We're in the home stretch, but we're not opening this bridge just yet. First, it has to go through rigorous testing and inspections. Engineers will put the bridge through its paces, simulating different traffic loads and environmental conditions to make sure it can handle the pressure. They'll use sensors to monitor stress points, check for any signs of weakness, and make sure everything is up to code. Safety is the top priority here, so they don't cut any corners. After years of planning, designing, and building, the moment has finally arrived. The bridge is ready to open to the public. This is the culmination of countless hours of hard work and collaboration, and it's definitely a time for celebration. There's usually a grand opening ceremony with speeches, ribbon cutting, and maybe even a few fireworks. And then, the first cars get to drive across this marvel of engineering, connecting communities and economies like never before. It's a testament to human ingenuity and our ability to overcome incredible challenges. So there you have it, folks. The incredible journey of building a bridge over water. From the first sketch to the final crossing, building a bridge over water is a triumph of engineering, teamwork, and vision. It takes a special kind of dedication and expertise to pull off a project of this magnitude, and it's truly inspiring to see these structures come to life. Next time you drive over a bridge, take a moment to appreciate the sheer amount of work and ingenuity that went into building it. It's a testament to human innovation and our ability to connect the world, one span at a time. Want more on mega projects? Subscribe and hit the bell.